In this video, I'm going to go through the second glaucoma case in which it is phacolytic glaucoma. So at low power, we have the cornea, which looks pretty normal. Note the angle is open and that the iris has got a corrugated anterior border. Same over here. What we have here is the lens and the nucleus is intact, but the cortex is all pale and fluffy looking. This is an artifactual divot here. When we look more closely, the lens capsule will be intact. Moving posteriorly, there's some cavernous degeneration physiological here, and the retina looks pretty good and attached. And then over here, we've got a hint that there might be a cup. The nerve does not swell out beyond the cribriform plate, and so this indicates that there might be some nerve atrophy. Okay, let's go to the front of the eye. So we confirm that the epithelium is normal and there's normal basket weave and the endothelial cells and desmomes are normal. But here in the anterior chamber, we have got debris. In fact, the debris here is fluffy material. It might be in macrophages, but probably isn't. Let's move back to the trabecular meshwork here. See the fluffy debris goes all the way around here. All right, so let's have a bit more closely examine what's happening here. So we've got the trabecular meshwork, canal of Schlemm, and then we can see here in the angle and on the anterior iris some macrophages. You can see the nuclei here and this proteinaceous debris. So this proteinaceous debris is coming from somewhere. At the moment, we go, oh, is it exfoliation syndrome um, or is it phacolytic glaucoma? We come here to the lens and we can see that the same material has come from the broken down area of the lens cortex. And that is what is causing this glaucoma. So now we go round to the back of the eye. We notice that there's a bit of sclerosis in the ciliary body, and then we go back here. We have the the cystic degeneration of the retina. I usually just scan through here because there really aren't that many changes. Let's have a look and see if there is lots of ganglion cells, and the answer is not really here. So we've got outer nuclear, inner nuclear ganglion cell layer, so that's all looking okay. So what that means is that the glaucoma has not persisted enough to give rise to ganglion cell layer loss. As we go posteriorly, this could be the fovea. Let's just go to low power. Yeah, so this is the fovea here, which of course is adjacent to the optic nerve, and we can see that this ganglion cell layer is really thick around here. All right, let's go to the optic nerve. Okay, so there might be early cupping here. The cribriform plate, though, really isn't particularly bowed, just a tiny bit. And actually, the optic nerve isn't too bad. There's a bit of cystic change here, which might be edema. I'm not convinced that that is optic nerve atrophy. So let's carry on around here. And I think that the rest of the retina will be pretty normal. Okay, so this was phacolytic glaucoma. We'll head over to the other side here. And again, we can see the angle is open with the trabecular meshwork just through here. But again, these macrophages. Okay, that's the end of that recording.